All right, what's up, everybody? It's Hutch here. This is Module 12, Lesson 4, and it is volume time. All right, now, volume, let's go ahead and break this down. The big thing you have to remember is volume, instead of being squares, like area, we're measuring volume in these shapes. And what are these? Cubes. So we're going to do a little mini 2 for squared and a little mini 3 for cubes. You can think of this as 2-dimensional and 3-dimensional. Okay, so when we're doing volume, we're filling a shape, and it is measuring the 3-dimensional amount of space inside. Okay, all right, now a couple things to be aware of. We have rectangular prisms. Okay, and their bases, remember those parallel sides, are rectangles. Okay, those parallel faces. And triangular prisms, where the bases, okay, which are the parallel parts, okay, and this is what I mean by parallel. Look at my drawings here. These two parallel faces are triangles. So we have prisms, triangular, rectangular, okay? All right, now, next thing. Let's talk about the formulas on here. So the volume, which would be represented by V, okay, is basically just multiplying the area of the base, and we're calling that big B here. So make a little note, okay, and this just means the area, okay? I don't know why I spelled area that way. So the area, so you have to plug in the area formula, whether it's a rectangle or a triangle, okay? And so just be aware of that, but the height is the height, okay? So big B is not a length, it's the actual area times the height. Because think about it, if we find the area of this space here, okay, and then we multiply it by a height, it's going to take that and stretch out the amount and fill up all the space. So area of the base times how tall it is, that fills it up, okay? All right, so let's go ahead and tackle this now. You're going to want to use probably Desmos as we get into the fraction stuff. Pay close attention to what you know, what you don't know, how they want you to represent it, all that kind of stuff. So we got a jewelry box in the shape of rectangular prism. What is the volume? So we're trying to find volume, round to the nearest tenth, use the volume formula. They don't care how we represent it in decimal or fraction form, so we're just going to stay decimal. Okay, all right, so we're going to go ahead and always write the formula, remember. So volume equals big B times H. Big B on this one, the area of the base, okay, is length times width, okay, because we're doing a rectangle. So it's length times width times height for this one. That's what big B is length times width, okay? So let's go ahead and plug that in. And so it doesn't really matter as long as you find the length and width of the rectangle, you're going to be good. I mean, you're multiplying all three parts. Just make sure you get all three. And so we have, if we look at this here, we have the 18.4 multiplied. So we're going to do parentheses by the width of 14.8 centimeters multiplied by the height of, and so here's our height, 25.6. All we're going to do is plug it all in. 18.4 times 14.8 times 25.6, and voila, you got your number. And so here we are with an overall volume of 6,971 point. And now I pause and look at where they want us to round. They just want us to round to the 10th. So instead of 0.3, we're going to stop at 0.4. Okay. We have centimeters, and because it's volume, we need to put cubed. Okay, so that's what you need to pay attention to. Okay. All right, there we go. Let's go ahead and try it on here. You can pause if you want, or you can just follow along with me. Remember, we're doing volume equals big B times H, where big B is the area of the base. So since the base is a rectangle, we're doing length times width times height. And so here we go. Basically, you just grab your three numbers and away you go. You have your length here, your width, Okay, so length, width, and then here's our height. Okay, so we're just going to plug that all in. It looks like you can probably use decimals for everything. 7/8 is 0.875. And so I think I am going to go ahead and do it all as decimals instead. However, remember I told you pay attention. We need to find the volume, but we need to write it as a mixed number, unfortunately, in simplest form. So if you are going to use decimals, you're going to have to click it back to the fraction form. Okay, but I still think that running this through as decimals is going to be a little bit nicer to type in. Okay, so let's go ahead and plug this in. So we have 14.25 times 9.25 times 1 point, and I think we said 875, yeah. Just easier to type in, and then we can switch it back. Okay, so here we go, 14.25 times 9.25. If you type it right, times 1.875, and there we go. Then I'm going to hit that fraction to decimal button. So here's the problem with running it in like this, is we have 31,635/128. So it's not written as a mixed number, unfortunately. So we're going to have to change it. So maybe it would have been easier to just type it in as a fraction. I'm not sure. We could always try that for the next one. Okay, so volume, we got 31635 over 128. Okay, we know that that is a whole number of 247. So we need to go ahead and write it as 247, and then let's go ahead and see how much extra there is. Okay, so I'm going to hit enter. 247 times 128, we have 31,616. So all we have to do is put the difference in the numerator. So let's see, 635 minus 616. We'll see what the leftover is. Okay, so 19. So 247 and 1928ths. Okay, and that is inches cubed. Okay, all right, so there is our official final answer there. That's the volume. Okay, let's go ahead and just see what it would have looked like if we ran it with fractions. So we have 1 and 7/8 times 14 and 1/4. Oops, mistyped that. 4th times 9 and 1/4. And it does give us that same kind of decimal that you'd have to change. Okay, so it doesn't really matter which way you do it. We're left with some weird stuff either way. Okay, all right, let's go ahead and move on to triangles now. So you do have to know what the area formula is for a triangle, because we know that the volume formula is big B times H, but big B is the area of the base. So area of the base, I know what it is, but I do want to model for you the process of just looking at your formula sheet. Okay, so you should go to triangles and be like, oh yeah, it's 1/2 base times height. Okay, so the area is 1/2 base times height. So here's what we're really plugging in here. So the volume is 1/2 base times height times the actual like length height. Okay, so that's where I would say this is a little bit funky. Is we're finding the area of this part here, and then we're multiplying by this height here. Okay, so we sort of have two different heights: the height of the base and then the height of the entire prism. Okay, so let's go ahead and start plugging this in. Okay, so we have 1/2. The base is 6.5. And the height of the triangle is 8.25. And then we're going to find that area and multiply it that distance of 15.3. Okay, so if you can try to process it like that in your head, then you'll be okay. We can also rewrite this. I sort of like doing it. Sometimes you could do it just all of that divided by 2 instead of the 1/2. But however you want to officially tackle that is up to you. Okay. All right. So let's go ahead. I'm going to actually put in the 1/2 as 0.5. So we'll just do 0.5 times 6.5 times 8.25 times 15.3. And there we go with our official answer. Volume equals 410. Now I always have to pause. Look how they want us to round. 100th for this one. So 0.23. Now units, inches, and it's volume, and volume is 3-dimensional cubed. Okay, there we go. All right, check this out. We have volume equals big B times H. We know that for this one, the area formula is 1/2 base times height. Instead of writing it, I can go ahead and plug it in. Now pay attention to what the base is of the triangle. Okay, so our base, I guess it doesn't really matter with this one because it's a right triangle anyway. So we could use this 7 3/4. So I'm going to put 7.75. The height of my triangle is 3. Okay, and then that gets me this area. Okay, and then what's the length of the entire prism? That is 6.25. Okay, so that's my H. So this is this, and then the B, big B, is right there. Okay, all right, now we just plug it all in. Okay, I'm going to do 0.5 times 7.75 times 3 times 6.25, and there we go with our answer. Okay, oh, bummer, as a mixed number, darn. Okay, well, here we go. Volume equals 7.265. That's our whole number, and then we're going to have leftovers. So let's hit the fraction button, and it shows it's going to be out of 8. Okay, and then we just have to multiply 8 times this to figure out then what the leftover is. So I'm just going to hit enter. We're going to do 8 times 7.265. That gets us 58120. And if you compare it to our answer above, you can see that we just have 5 extra, so 5/8. Okay, so there we go. Okay, so that is mixed number in simplest form. Okay, a little bit annoying that they're asking for it that way, but whatever. Okay, all right, now yards, and its volume, so we're doing cubed. Okay, there you go. All right, let's go ahead and take a look at pyramids. Pyramids have a different formula. Their formula is 1/3 big B times H. So instead of the normal big B times H, we have this extra 1/3 in front of it. Okay, so something to just be aware of. Big B still means area of base. Okay, so just be aware of that, and we just look at the size of the base, because we know that some pyramids can be triangles and some pyramids can be rectangles. Okay, so it's either going to be 1/3 length times width times height, or 1/3 1/2 base times height. Okay, so same sort of concept. Let's go ahead and tackle this. Pay attention though, the height for this is in the center going up to the apex. Okay, that's the height. Okay, all right, so this one we don't have a picture, we just have words. It says a rectangular prism and a rectangular pyramid each have a base area of 150 square inches. The prism and pyramid have the same height if the volume of the rectangular prism is 600 cubic inches, what is the volume of the rectangular prism? Okay, so here's why they're posing this problem. Okay, so you know a rectangular prism, its volume is area of the base times the height. The pyramid, the one difference is it's a third of that. Okay, so they're saying to you that the rectangular pyramid is 600 cubic inches. Okay, and they're saying, well, if the rectangular pyramid, okay, this one is 600 inches cubed, what would the regular prism be, this one, if it has the same base? Okay, so same area. What's the only difference? Well, the pyramid is a third of the size. So technically, if the pyramid is a third of the size, what should the actual prism be? Well, it should be 3 times that, right? So 3 times 6 is 18 with the 2 zeros, and there we go. So that should be the regular one. So if we know what a regular prism is, then we can figure out what a rectangular pyramid is if they have the same base areas. Okay. All right, let's go ahead and try out this one here. Use the formula to find the volume. They're not telling us it has to be in fraction form, so we can go ahead and use decimals if we want. It's really up to you. Okay, I think it's just easier to type in the decimals. All right, let's start by writing the formula. So 1/3 big B is the area. Okay, so we have to right now plug in the area, okay, area of the base, and then we need to plug in the height of the pyramid. Okay, so how do we find the area of the base? Well, let's look at what the shape is. It's just a rectangle. Okay, so area is length times width, right? Okay, so we have 3 and 1/5 is just 0.2 times 1.5. And what's the height of it all? Okay, the height of it all is 2 and 4/5. So if 1/5 is 0.2, 2, 4, 6, 8, so 0.8. So 2.8 is the height. Okay, let's go ahead and plug this all in. Now here's the problem with this is we can't use this as a decimal. Okay, so we're gonna have to do some other work. One other easy option is just to, instead of doing it like this, take this whole answer and divide by 3. Okay, because that's what 1/3 times that actually is. So that's what I'm gonna do instead. Okay, and so we'll do our 3.2 times our 1.5. We get that. We'll do times 2.8, and we get that, and we'll take the answer and divide it by 3. Okay, so we get a volume of 4.48. Let's see where we're supposed to round to. It does not say, so we'll leave it at what it is, and it is in inches cubed. Okay, so there's that. Just to show you it's the same thing, we could do fraction 1/3, and then over, and then times, in parentheses, 3.2 times 1.5, and then other parentheses, 2.8, and you get the same thing. Okay, so 2 ways of doing it, both get the same answer. All right, go ahead and pause and try this, or you can follow along. We're finding the volume of this pyramid. We know volume equals 1/3 big B times H. Okay, so let's go ahead and plug this in. So 1/3, and then area of the base. Look at what the base is. It's just a rectangle, so we're doing length times width. So 1.8 times 2.2. And then what's the height of the pyramid? It's 2.9 centimeters. Okay, so let's go ahead and plug this in. Okay, I'm going to go ahead and do the original way I did before, which is 1.8 times 2.2 times 2.9, hit enter, and take the answer and divide it by 3. Okay, so So volume equals 3.828. Let's check rounding. Rounded to the nearest hundredth, so we're cutting it there. So that actually needs to turn into a 3. Okay. All right, and then it is centimeters, and because it's volume, we know it's 3-dimensional, so we say cubed. Okay. All right, let's go ahead and move down to this. Okay. So this time is just that reverse where we have the volume. So it's nothing different. You're just going to plug in what you actually know. Okay, so volume equals big B times H. In this case, or sorry, 1/3 big B times H. Remember, you don't have to remember them. Okay, you can look at the formula sheet every single time. Okay, so let's go ahead and plug this in. We know the volume, which is V, and so we write 180, okay, as that number. Okay, equals 1/3. Okay, do you know the length and the width? Yep, we do, of that base, right? Area of the base. You can see the thing we don't know is the height. So that's our variable that's going to stay h. Okay, so our length times our width is 10 times 9. So if I want to be a little quicker, I could just make it automatically be 90, and that's fine too. And then we have h. Okay, so now we do have to go ahead and do some solving. So separate your workspace to do your algebraic work. Okay, we have 1/3 times 90, or just 90 divided by 3. And that's a nice quick mental math one. Okay, and so right now we have 180 equals 30 times h. And all we have to do to get rid of that 30 times h is divide both sides by 30. Cross that out, and we end up with a height of, let's go ahead and plug this in, 180 divided by 30, and we have a height of 6. And there we go. Now, this is 6 inches, and it's just a length, okay, from that center to the top. So we leave it at 6 inches. Okay. All right, let's go ahead and check out this one. So we're using volume to find the missing dimensions. Now we have a prism, okay, and you can see that the base is a trapezoid, so we would call it a trapezoidal prism, okay? And so we still have the same formula, okay? The thing that we don't know, okay, is, let's see, we know the volume. Okay, so we have that. They're asking what is the area of the base. Okay, so there's something we don't know about the base. So first thing I would do is identify the base. Okay, and so one of the things that we know is here is the trapezoid base. We know this. We know this. Okay, but we don't know the height of that trapezoid. Okay, in order to find the area. Okay, we do know this sort of length of the prism, or what we call height. Okay, so let's go ahead and take a look at the trapezoid formula for a trapezoid. Okay, so let's see where it's at on here. Regular trapezoid. Okay, so this is the formula for the area of a trapezoid. Okay, so we have a little bit of work to do here to identify things. So B1 and B2, okay, are here and here, and we know that, okay? We just don't know this particular H here, okay? But we can do everything else and work our way through everything here, okay? So let's go ahead and start laying this out and figuring stuff out, okay? So set up your volume formula. Okay, volume equals big B times H. I try to keep it simple like that first. Okay, now let's start to fill out some things that we know. We know the volume is 195.075. Okay, equals. And then we have the area of the base. Okay, the area of the base is this particular formula. Okay, that we have on the formula sheet. Okay, so it's 0.5, okay, times h, which we don't know. We don't know the height of the trapezoid, okay, And all that is times B1 plus B2. Okay, so let's go ahead and add up B1 and B2. It's 11.45 plus 5.25. So we have 16.7. Okay, all right, and then we're multiplying all that by the height of the actual prism itself, which is 7.65. Okay, so you can see how I break that down to sort of take my time with it. Okay, let's do all the multiplication that we can do. Okay, so that we're just left with a number multiplied by h. Okay, so I'm going to separate my workspace here, and we're going to end up with 195.075 equals, and let's go ahead and multiply all this together. Okay, so calculator out, and here we go. So this is 0.5 times 16.7 times 7.65. And we're allowed to just multiply all over the place because we have all multiplication, and because of the commutative property, it allows us to multiply all those things in any order, only because it's all multiplication. Okay, all right, and so we end up with 63.8775 times h. Okay, and now we just follow our normal things that we would do. Let's get rid of that from h. Divide that on both sides. I don't really like this problem, but it does show that if we follow our rules of math, it'll all work out the way it should. So what is the height of our trapezoid? Well, the height of our trapezoid is, let's go ahead and plug this in, 195.075 divided by 63.8775, and we get this really, really long number. Okay, are they having us round it at all? Because of the shape of the two parallel congruent bases or trapezoids, you know the volume and the height of the prism. You need to find the area of the base. Okay. All right, so the height is 3.053892216. So that's the height. They want us to find the area of the base. So now that we know the height, we can actually plug that into our formula here, okay, to get just the area of the base. Okay, all right, so let's go ahead and do that, okay, and see what we would get. So 0.5 times, we'll put in our height of our base, 3.053892216 times 16.7, and there we go. We get a nice simple area after all that. All right, so area of base equals 25.5, and that's centimeters. Now think about it. Is area squared or cubed? Area is squared. Okay. Now as I go through this, I'm sort of thinking, I feel like we could have also just, because we know this whole thing is area, we probably could have just done 195.075 equals, and just call it big B, times h, okay, and just solve for big B. Let's see if we get the same thing, okay, in a lot quicker way, because they were just wanting us to find the area. And if big B is area, we should be able to just simplify it like this. So let's try this out. 195.075 divided by 7.65, and yep, there we go. That was a way quicker version. okay? So that just tells us that big B, or the area of the base, is 25.5, okay? All right, so same type of thing, two ways of doing it. It's good to see the other way too, so that you can see how all the math works and functions, even with some really long, crazy numbers, okay? All right, go ahead and try this out. We have a pentagonal prism, okay? And so with the pentagonal prism, okay, they're asking what is the area of the base of the prism, okay? And so you know the volume, and you know the length of, or the height of the prism. So we just want to know what B is. And so we don't actually need to know the formula for a pentagon, area of a pentagon, because we can use our strategy that we just did right here. Okay, so let's go ahead and imitate that for this one. If you want to give it a try or follow along, up to you. Okay, so it has a volume of this many cubic inches, and they're asking what is the area. Okay, all right, so let's go ahead and take a look. We have volume equals big B times the height or length of the entire prism, okay, is how you can think about it. All right, we know the volume is 124.8, okay, well, that's what 4/5 is, equals, and we'll let big B stay big B, because that's what we're trying to solve, is just what is the area. And then we know that the height is 8, okay? All right, so we can leave it right like that. Let's separate our workspace. We just divide both sides by 8 and cross that out, and we should have our, oops, cross out the wrong thing. Cross that out, and we should have our answer already of what the area of the base is, okay? So 124.8 divided by 8, and there we go. Okay, now think about what this is. It's an area of the base. So this is inches, and is it squared or cubed? Well, it's area, so there we go. Okay, all right, let's move down to here. Okay, use the volume to find the missing dimensions. Here's the model of the Great Pyramid of Giza, and it has a square base with sides that are 15 inches long. If the volume of the model is this, what is the height, is what we're trying to find, okay? And so they're not telling us the area, but we can figure out the area because they're telling us the length and width of that base, okay? All right, it says, use the formula, volume equals 1/3 base times height to find the height of the pyramid, because we're on that pyramid formula now. Okay, so a little bit different than the prism one. Okay, so we have volume equals 1/3 area of the base times the height, and let's start plugging in some things that we know. Okay, we know the volume is 675, so we can plug that in. We can leave our 1/3. Do we know the area of the base? Well, we do, because it's a square, right? So it's going to be this shape here. Okay, and a square is length times width, which is 15 times 15. So let's go ahead and do that. And so we have 225, okay, as the area. And then the height is unknown, so we're just going to leave that h. Okay, so now we can go ahead and solve for h. So we're going to take care of this first. Okay, 1/3 times 225, or 225 divided by 3, same thing. And so we end up with 675 equals 75h. Okay, let's go ahead and divide both sides by 75. And we end up with our answer of a height of 675 divided by 75, and we have a height of 9. Now what's the unit? It is in inches, okay? That's just a distance, a linear distance, so we leave it at that. All right, let's go ahead and try the check here. You can pause or follow along with me, okay? Highlighting stuff I know. We have a volume here asking what is the height, okay? So I'm gonna set up my volume formula. Let's look back up. Oh, remember this one's formula is 1/3 area of the base times the height. So let's plug in what we know. We know the volume is 266.25 equals 1/3 area of the base. Okay, it's a rectangle, not a triangle. So we can just do length times width. We're going to have to plug that in as a fraction because 5/6 is a repeating decimal, unfortunately. So 11 and 5/6 times 4.5. All right, and that didn't turn out too bad. Okay, so area of our base is 53.25. And do we know the height? Nope, we don't know the height, so that's going to be our h. Okay, so separate your workspace, and let's go ahead and solve away. So we're going to take care of this first. So we have our 53.25 divided by 3. And so we end up with 17.75h equals 266.25. Go ahead and divide both sides by the 17.75. And we end up with a height of 15 inches. And there we go. There's our height. All right, so here's our applies, and then we'll get on to the practice and homework. So Lee's mailing a candle, and it has the dimensions shown in the rectangular box. That is 4.2 inches long, 5.8 inches wide, and 7.6 inches tall. If one bag of packing material holds 25 cubic inches of material, how many bags is she going to need to fill the space around the candle? Okay, and so what you have to realize here is the shape that you see. What is this? Is this the box or is this the candle? Okay, she's telling you she's mailing a candle that has the dimension shown, and she's mailing it in a rectangular box. Okay, so if the bag of the material holds 25 cubic inches of material, how many bags does she need to buy to fill the space around the candle? So you have to picture this rectangular prism around this. Okay, and they're giving us the dimensions for that, and we want to know how much blank space there is. Okay, so we're going to find the volume of both of these and subtract to find that empty space and use that to answer our question. Okay, so let's take care of our rectangular prism because that's an easy formula, right? It's just volume equals length times width times height, because volume of a base is length times width. So super quick, easy formula. Let's go ahead and label this. So we'll label this our rectangular prism. So we have volume equals 4.2 times 5.8 times 7.6. Okay, so 4.2, 5.8, 7.6. I'm just showing my work real quick. And we have 185.136 inches cubed. So there's my rectangle. Okay. All right, let's go ahead and do this triangular prism. Okay. Triangular prisms are still the same formula. Okay, so I'm just going to label this as triangle. So we have volume equals big B times H. Big B is just different for a triangle, right? Big B is 1/2 base times height. Okay, so let's go ahead and fill this one out. So we have volume equals 1/2. Our base is 3.4. The height of our triangle is 2.6. Okay, and then the height of the length of the entire prism, we call H, is 5.5. Okay, so let's go ahead and get our answer for this one. So I'm just going to do 0.5 times 3.4 times 2.6 times 5.5. And we get 24.31. And that is also in inches cubed. All right, so there's our two shapes, are the volumes of both of those. Let's go ahead and subtract these and find out how much empty space there is. Okay, so we have our 185.136 minus the candle, which is 24.31. Okay, and we have an empty space, call it, volume of 160.826 inches cubed. Okay, so that's how much empty space is in there. It says a bag of packing material holds 25 cubic inches of material. So how many bags are we going to need to buy? So let's just divide this up into bags, which are 25 inches cubed. And let's see what we got here. So we can just hit enter, answer divided by 25. And let's sort of think through this. Is the answer going to be 6 or 7? We're going to need 6.4 bags, but you can't buy that, so we're just going to have to buy 7 bags. Okay, so we need 7 bags. Okay, so there you go. Okay, all right, that's our official answer. How many bags does she need to buy? We need 7. All right, so here is your work. I sort of shrunk this down a little bit, so you just have 4 problems to practice here, and then 2 just word problems. You're going to pay attention to what these are. We got triangular prism and a rectangular pyramid. So you have to go back to those formulas to figure out what to do. And then one apply that is very similar to what we just did, where they're mailing a photo box that has the dimensions shown in a rectangular box. So in this one, we just have 2 rectangular boxes, and you do need to figure out the empty space and how many bags of packing material we need. So same as we just did in the notes. Okay, so there's your work. Go ahead and get started on that. Let me know if you have any questions.